Hello everyone. So let's continue to learn inferential statistics. In this we'll be seeing what is probability and what is the significance of probability in data science. So let's first see what is probability. I can say that chance of occurring of a particular event is called as probability, or to estimate how likely something is to happen is called as probability. So you must be thinking, what is something? What is an event? So event can be anything like playing a football match, falling of a rainfall, getting a movie ticket. Now, if I want to find out in a football match, let's say I will want to find out whether the player Arsenal will win or Chelsea will win. Now, what is the probability of winning both the players? Or what is the probability that who will win? How will I find out? Or what is the probability that the rain will fall in the month of July in India? Or what is the probability of getting a movie ticket of, let's say, very famous Bollywood star Shah Rukh Khan? Then, on a first day, first show, what is the probability of getting a movie ticket? So, to answer all these questions, I need recorded data. I need historical data. So, let's say in the football match, I have the recorded data of 10 matches. In 10 matches, 7 times Arsenal will win and 3 times Chelsea had win. So, I can say that the probability of winning of Arsenal in this match is 7 by 10, that is 0.7%, because it is based on the historical or the recorded data. So I can find out the probability or estimate the probability based on the historical or recorded data. So let's say in the month of July in India, the probability of rainfall is 0.4%. Similarly, getting a movie ticket on first day first show of a famous Bollywood star is 60%. Or getting a baby boy or baby girl is 50%, because either a boy will happen or a girl will happen. So we can say that we can draw our previous experience to determine how likely something is to occur. So the chance of winning is of Arsenal is 0.7, chance of rain to occur is 40%, chance of getting a movie ticket is 60%, and so on. Now, let's say what are the different probabilities of different types of event. Let's say I take up a simple example. I say sun rise from west. Now, what is the probability that sun will rise from west? So this kind of event is an impossible event. So the probability of an impossible event is 0. Now let's take up a very simple example of rolling of a dice. We all have played with dice. So dice has 6 faces, and on each face it has one number 1 to 6. Now I want to find out what is the probability of getting a 4. Now 4 is only on one face. So it will occur 1 out of 6 times. So the probability of getting a 4 number is 1 by 6. So this is an unlikely event. If I take an example of tossing a coin, in tossing a coin, either I will get heads or I will get tails. So the probability of getting both the chances is equal. So I say that probability is 50% or 0.5. Similarly, if I take up an example of a software company, I say that out of 5 people, 4 people are software engineers, because I am taking an example of a software company. So the chance of picking up a software engineer is 4 by 5. So it is a likely event. And something which is very certain, let's say sun rise from east. This is very certain. So the probability of sun rising from east is a certain event, and it is probability is 1. After understanding what is probability, the question comes, why is probability essential? Now, if I take up the previous example of calculate the poll sentiment of a particular country. Now, if I calculate the poll sentiments from a sample and I generalize the statement to the entire population, then what is the certainty that my statement is correct or my conclusion is correct? So to provide that certainty, I need probability. So probability adds certainty to my conclusion. So it is very much important. So let's take up a very simple example. If the credit score of a particular person is 70%, then the probability that the bank will give the loan to that person is 70%, right? Otherwise, the person will not get a loan if the credit score is less than the 70%. So probability adds certainty. So basically it substantiates your conclusion so that you can have a valid proof that based on the historical data you have made and drawn these inferences, and this adds certainty to your decision making process. Let's take up another example of a university campus in which various students occur. So students who studied from the university, who are exchange students, who have enrolled for the correspondence course, who are studying from home, and who have just graduated. And I want to find out what are the job prospects of each category of students. Now, to find out the job prospects, I take a subsample of data. Let's say I'm assuming that in a college canteen, all these categories of students are sitting, and I surveyed all of them, and then I can find out that what is the probability of getting a job when the student is studying from home and when the student is studying from university and correspondence and for other various categories. So this is how probability is very important in data science. Now, there are certain components of a particular experiment. If I'm talking about components, I am talking about sample space, event, and sample point. Now, take up a simple example of rolling of a dice that we've already did. So, dice has 6 faces, and in 6 faces, it has number 1, 2, 3, 4, 5, and 6. Now, all these points like 1, 2, 3, 4, 5, and 6 will compose of my sample space, right? So this is my sample space consisting of all the sample points. So each point is called a sample point. This is sample point, and all the possible outcomes or sample point is called as sample space. So every possible outcome of a particular event is called as a sample space. Now, event is something that let's take up an example like what is the event likelihood of getting an even number. Now, even number can either be 2, 4 or 6. So, there are 3 possible outcomes, right? And out of how many possible outcomes? Total 6 possible outcomes, right? So, 3 by 6. So, I can say that the likelihood of getting an even number is 3 by 6 or 1 by 2. Similarly, likelihood of getting an odd number is also 3 by 6 which is equal to 1 by 2. Now, event can be an event or it can be a negation of an event or complement of an event. So if I'm talking about even numbers, so getting an even number is an event. So what will be the complement of that event? Getting an odd number from a dice will be a complement of that particular event. So decision trees can also be used to find out the probability. Let's take an example that I want to buy a new car. Alright. So buying a new car depends on many factors like what is the model, what is the mileage, what is the version of the car and various other factors. I take up a 3 simple factor. Either I can buy a hatchback car, either I can buy a sedan car, or either I can buy a SUV car. Okay. Now in SUV car, only diesel version is available. In sedan car, petrol, electric and diesel versions are available. And in hatchback car, petrol and diesel versions are available. Now, which car to buy? Now I don't want to buy an SUV car. It's possible. Or let's say I don't want to buy a diesel car. Now, if I don't want to buy a diesel car, I cannot buy an SUV car because SUV car is only available in the diesel version. So, one possible option is excluded from my conclusion. Now, I have two options. Either I can buy a hatchback car or I can buy a sedan car. Now, let's say I want to have a good boot space. Now, to get a good boot space, I can buy a sedan car and I can take any other car, either a petrol car or an electric car. So hatchback option also gets excluded. So I can buy a sedan car and I can buy any version, either petrol version or electrical version based on my choice. So this is how decision tree gets us to reach our conclusion. So the possibility of buying a sedan car was, so I had 3 options. So the probability of getting a sedan car is 1 by 3. And the probability of getting a petrol car was 1 by 2 because petrol car was available only in hatchback or in the sedan version. So this is how decision tree and probability can be combined. Now if I talk about different types of event, so I have independent event and dependent event. Now if I'm talking about dependent event is something which is dependent on one another and independent event is something which is independent of one another. Now, if a group of people is watching a movie in India and a group of people is watching a movie in Australia, now these two are independent events. Why? Because they are watching different movies of different genres at different locations. So nothing is common in them. So these are independent events. But if I want to find out the spike of sales of umbrella in Walmart, then this is dependent upon rains and thunderstorm. Now this type of event is called as dependent event. Now there are two types of probability. One is mutually exclusive and the other one is non-mutually exclusive. So if the two events or if the two outcomes of an event cannot occur at the same time, I can say they are mutually exclusive events or mutually exclusive probability. For example, tossing of a coin. If I toss a coin, either I will get heads or I will get tails. So these two events cannot occur at the same time. So these are called as mutually exclusive events. And if I want to take out a card from a deck of cards, playing cards, and the card should have an heart and a king. Is it possible? Yes, we can have a king and with the heart sign. So these kind of events are said to be mutually non-exclusive because they have at least one common outcome from all the events. So this is about probability, different types of events, and what is the significance of probability in data science. In the next video, we'll be seeing what is conditional probability and how can we use it. So for all such videos, please stay tuned to my channel. If you have not subscribed my channel till yet, I request you to please subscribe my channel. And for more such interesting videos, do comment me in the comment section. Thank you all.